Hello everyone and welcome to our 11th STEAM Sunday video. Today we're going to be doing a super simple experiment to investigate water density. And what we're going to be doing is making our own lava lamp. So really easy to do, but you will need a lot of oil. So it might be worth going out and finding the cheapest oil you can, because you need 3/4 of a bottle full. We've got water for the rest of the space, food colouring to show where the water goes, and some Alka-Seltzer, I think that's how you pronounce it. Basically fizzy aspirin. You can get them really cheaply in the shops. Please remember not to just eat these or take them. They are medicines and should be used responsibly. And something else that you might want to have for this is a small light, because it really lights up what's happening inside your lava lamp. And there we are, it just adds a little glow to what we're doing. So I'm going to go ahead and just pour water into this oil, and you can see instantly that the water heads down to the bottom. Leave a wee bit of room at the end. You'll see the water is layered down here. It's made sort of bubbles in the water, which is really nice. You can see them moving around inside. And we're going to get in nice and close once we activate this lava lamp. So I'm going to go ahead and add in quite a bit of food colouring now. You don't have to use much, but I really want to add quite a lot so that we can see this awesome effect. And now we're going to pop in an Alka-Seltzer tablet. So I'm just going to halve this so it fits into the bottle. And as it starts to dissolve, you'll see the bubbles rising up out of your lava lamp. Now, something that I'd forgotten about was the fact that the tablet dissolves, so of course it creates a gas, and that builds up a pressure inside the bottle, so you'll need to release some air. So you might need to go to a sink or outside and just release some of that pressure if you've not left enough room. And this works because the water is heavier than the oil, so the oil floats on top of the water, and they're insoluble. They can't actually mix. The oil doesn't dissolve in it, so they're very separate layers. A tablet then drops down into the water, fizzes, and those air bubbles are obviously the lightest thing, so they rise to the top until the gas that's been released pops at the top, and then the water comes back down because it's heavier than the oil, which is how you get these sort of sinking and floating effects going on inside. And in real lava lamps, it's not necessarily water and oil that they use. They use two things that are much closer in density, but still insoluble, so they sit and form two layers, and then they use the heat of a lamp in order to heat up the lower liquid, and of course heat rises, so the lower liquid then rises above the top one, and when it cools down at the top it comes back down, and that's how you get that mixing effect in a real lava lamp. So there we are, make your own lava lamp. It will be a bit messy if, like me, you get it a bit wrong at first, but that's okay. Just make sure you've got a good surface, that you don't mind giving a wipe down afterwards. As always, if you take part in this experiment, remember to tag me on Twitter at Mr. Feistclass and use hashtag STEAMSunday if you take part. And a big thank you again to everyone who subscribed to me on YouTube recently. It really does help, and I'm starting to put a lot more content on YouTube for teachers and for children. And I'll be putting a huge series of how to code using Scratch over the summer holidays, so do tune in for that. I'll see you next week.